In this video, we're going to look at section 2.4 box plots, and then we'll see how far we get with the other kinds of graphs. So this is a box and whisker plot, it may be called. They give a good graphical image of the concentration of the data. They also show how far the extreme values are from most of the data. It is constructed from 5 values. We call this the 5-number summary. The minimum, the first quartile, median, third quartile, and maximum value. So we're going to construct a box plot for the following data that represents the heights of 40 students in a statistics class. So in this data, we can clearly see the minimum and the maximum. We could probably even find the median, but it's really nice just to plop it in there and get the graph to see the picture. So I am going to switch over to the Staplet. And you can copy and paste this data as well and pause the video and try it. We've played around with that enough that you may be able to figure that out, or you can work along with me. Okay, so we are going to copy and paste this data. Just hit Control C, and then I'm going to pull up the Staplet here. Again, I'm going to put the title in as heights of students, just to remind you too before I do that. I'm going to go back to the menu. So just do staplet.com. This will pop up, and you want quantitative data for these ones. So one quantitative variable single group. And then we're going to write in heights of students. And you can be brief with these problems here. Data, I already copied it. Now I'm going to hit Control V and paste. Or you could just, right click and do paste, or however you paste if you're using a phone. And then I'm going to hit Begin Analysis. And again, my dot plot is the default. And we're going to look at box plot. And we can see all our values. You can see how the data is concentrated here between around 64.5 up to 70. And if I hover on it, I can see that. My label is there. Summary statistics. I have my N is 40, mean is 67.2, standard deviation is 4.3, minimum 59, first quartile 64.5, which again, right here, if I hover, and then median 66, but it lists it out for me too. Quartile 3 is the 70, and max is 77. So this gives me my 5-number summary right there, and creates my box plot. And if I had outliers, they would show as dots on here. So now I'm going to go over to the next page here. And this is just a picture of what we did to find the box plot and how we got the summary statistics as well. Now we'll move on to talk about the 5-number summary. Again, is listed here, and I always jot down my mean and standard deviation. Mean is 67.2, standard deviation is 4.3. So I'm just like getting the essentials written there, and then I might need to use them. So in this case, interquartile range is what we want to look at. That's that middle chunk of the data that you see, that box. That's why it's nice to have that box to see where the brunt of the data is. And to find the interquartile range, we call it IQR. It's just Q3 minus Q1. So if we have these numbers 64.5 and 70, we just go ahead and find the difference is 5.5. It's always going to be a positive number. And it can help you determine potential outliers. And if it's less than 1.5 times the IQR, we below the first quartile, or more than that, above the third quartile, then we will have anything past that as an outlier. The fences, we have to figure out the lower fence. We would take the first quartile, which is the 64.5, and we'd subtract off 1.5 times 5.5. And using order of operations, that would be 64.5 minus 8.25 to give us 56.25. So any values in our data set, which if I recall, I don't think we had any, but we could double check that, that would be an outlier. Pause the video and try to find the upper fence on your own. Okay, I'm going to show what that is now. So the upper fence is the third quartile plus that same value, 8.25, so we get 78.25. Okay, just a note to say we do not plot fences, but calculate them to determine outliers. We do plot the actual outliers if we have any. Staplet will mark this with a dot. On our box plot, we do not have any dots there, so we do not have outliers. And we could look back at our data and see that we don't have anything above or below those values. Just for fun, I did a histogram of the same data just so you could see the layout. Now we're going to look at measures of the center of the data, which we've been working with a little bit here and there as well. So it's a way of describing location. The two most widely used measures of the center of the data are the mean or average and the median. So you've worked with these a bit. To calculate the mean weight of 50 people, add the 50 weights together and divide by 50. To find the median, you would sort the data and then find the upper half and lower half, get that middle value. The median is generally a better measure of the center when there are extreme values or outliers, because it is not affected by the precise numerical values of the outliers. So just kind of keep this in mind, that median is the most resistant to extremes, where mean could be really affected. Let's kind of think about how that would work. You know, if you had a really high number, it's going to bring that average up, even if it was just on the, one number out of the bunch, but the median wouldn't even be affected at all. We often use the mean, but we want to look at mean, median, and mode as well. And when they all align and they're the same, we will have a normal distribution, which is nice. So here's an example, 2.26. A hospital administrator keeps track of the ages and years of patients visiting the emergency room over a 1-week period. The data are sorted from smallest to largest. And we want to calculate the mean, also known as X bar. You might see it like that, X with a bar over it. And the median might be written with this little symbol. It's called a tilde, X tilde. Also, we call it quartile 2. Or sometimes it's just capital M, small ed, med. So pause the video and try this on your own. You can use Staplet, you can use a calculator, you can look at the data, do it by hand, however you want to try it. Go ahead. Okay, now I'm going to reveal the answers. The mean is 23.6 and the median is 24. So they're pretty close. Now let's look at another data set. This is the mode we're going to look at, the most frequent value. There can be more than one mode in a data set as long as those values have the same frequency and that frequency is the highest. A data set with two modes is called bimodal. Find the mode for the following data representing the heights of 40 students in a statistics class. So we just use this data too. And you could look at the dot plot or a histogram with interval of 1. So I've already showed you how to get in there and do these things. So use the Staplet, or you could count up which one's the most if you want. Mode is 65. You can see it really easily in the chart here too. Calculating the mean of grouped frequency tables can be a little bit difficult. Staplet is kind of challenging to get those in there. Basically, it's kind of easiest to do it by hand in this case when we have small sets. If there's homeworks specific, I'll make videos that go along with that to try to help you along. But I don't think you're going to come across that too much. We will see probability distributions later, and we'll need to use that. We also finding like the weighted mean of some grades, which are usually small sets. Using a frequency table, you would use this method right here, and you can just do it by hand. Or you can do it with a calculator or something as well too. So if we have the survey of the 40 mothers, again, that asked for chores to be done, here was our frequency table. And what we need to do is just multiply these numbers together. So the number of reminders, so you're just going to take that first row, column 1, and multiply it by column 2. So 0 times 2 would be 0. Then do the next one. You add on 1 times 5 is 5. 2 times 8 is 16, so on and so forth. So go ahead and calculate those out. You can pause the video. Okay, here's how it lays out. The mean is this means adds up, the sigma of the, or the sum of the frequency times the value. And then we're going to add up all those values. I just did that calculation out here. So we had 0, 1 times 5 is 5, 2 times 8 is 16, so forth. I have 42 plus 28 plus 20, and add those and divide by 40, and you get 2.8. That kind of makes sense because the 2 and the 3, it's somewhere right around there. One way you could look at this again to get that frequency table is using a dot plot. Okay, here are some more practice problems, examples, however you want to do it. You work along with me or just watch. It's best if you try to do them on your own and then check against the video though. So we have this example 2.17, the following data represent the travel times in minutes to work for all 7 employees of a startup web development company. Compute the population mean and the median of this data. We're saying population because we're only looking at those 7 people. That's the entire group. So it's really the parameter. that we're finding. Round the answer to the nearest tenth. So my values are 23, 36, 23, 18, 5, 26, and 43. And then I need to get that sorted to find the median. So I did that. To find the mean, you can do it by hand. Just add up the numbers and divide by the total. And median would be the middle value. So you can try that, or you can try just popping it into Staplet. Whatever works best for you. Go ahead and get that taken care of. Okay, I'm going to reveal the answer now. The mean is 24.9 and the median is 23 minutes for all employees. So those are fairly close together. Next, we're going to look at if we add a new employee in. The new employee is living 70 minutes away. Determine the mean and median of the new data set. So now we have 8 is our n value, and we have this 70 to consider. So you could use the same process, or you could use Staplet. Just to note, this example 2.15 was the original problem. It stemmed from a little bit back in the book. Mean is 30.5, median is 24.5. See how the mean changed? It went up based on that high value. But the median, while it went up, it didn't go up a lot. It's just because we had that even number, so we would take the two middle values and average them. Let's now look at if we have someone who has a 130-minute commute. How does this impact the value of the mean and median? What do you want to guess? So go ahead and pause and crunch those numbers. But you could kind of think about what the expectation should be. Okay, I'm going to reveal the answer now. So we add on that 130. The mean is 41.56 and the median is 26. The mean is affected by the new value. Median is not affected much. It's affected a little bit, but not that much. Okay, so in the next slide, we are going to look at more problems for you to practice. Example 2.20, what is the mode for the weights in pounds of the 10 students in the nutrition class? So we have 95, 117, 210, 154, 193, 117, 130, 133, 268, and 145. You can sort those out, or you can just count up. It's kind of easy to see just by the numbers because it's a small set, but you can copy and paste that or type it right into Staplet and use a dot plot and you'll be able to find that, or do a histogram with just an interval of 1. Make sure you only have an interval of 1 or else it won't come out right. The next problem, so you can pause and do that one and this other one at the same time. Example 2.21, using the sample data set of colors, find the mode color. Be sure to interpret your answer in context of the problem. So we have blue, blue, green, red, red, blue, red, blue, red, red, green, blue, green, green. And again, you can put that in Staplet, but you will need to use categorical data, not quantitative. And I think we did that back in the chapter 1, but I will show you that if you're not getting it, but go ahead and try. And again, you can probably just count them up and see, you know, which one has the most, but it's nice to have a little graph. So pause the video and do that. Okay, I'm going to show the answers, see how you did. Mode is 117 pounds. In the color, we have two modes. So we say bimodal. They are red and blue. I'm going to pull up the Staplet just so I can show you what that would look like in a graph. Okay, so I pulled up Staplet, but I still have my old stuff in there. So I'm going to go down and go back to menu because I need an entirely different thing. I have copied and pasted this data here for the colors. I'm going to go to categorical variable single group. And I'll put in the title as colors. I want to actually put in raw data for this one, but you could do it as a distribution chart if you wanted to, a frequency chart or table. I'm going to do raw data. So I want to choose that in the drop down menu and then click it in here and paste and then begin analysis. I'll make that larger for you so you can see the differences here. We've got 5. If I hover, I can read it up above. So there's 5 for blue, 4 for green, and 5 for red. So 2 modes or bimodal. Okay, now we're going to look at skewness and the mean, median, and mode. This is a picture of a symmetrical histogram where the mean, median, mode all line up together. You could draw a line through and it's a mirror image. Skewed distributions, if I have this data, it's 4, 5, 6, 6, 6, 7, 7, 7, 7, 8. It's not symmetrical. The right hand side seems chopped off compared to the left side. So like it's just got this higher front on the right, but we call it skewed left because it's making a tail or being kind of pulled out to the left. That's like the lower numbers for skewed left. It's almost a little counterintuitive if you think skew is like the smaller. And the mean is 6.3, the median is 6.5, the mode is 7. The mean is less than the median and they are both less than the mode. The mean and median both reflect the skewing, but the mean reflects it more so. So when the mean is less than the median, we'll have a left skew. If I have this picture here, the data is 6, 7, 7, 7, 7, 8, 8, 8, 9, 10. So I have more lower numbers here. And my skew or my, I have less frequency of the higher numbers. So that's skewed right. So my mean is 7.7, median is 7.5, and the mode is 7. The mean is the largest, the mode is the smallest. The mean reflects the skewing the most. So our mean is bigger than the median, so I have a right skew. So this is what we said earlier. To summarize, in general, if you have the mean less than the median, you'll have a left skew. If it's greater than the median, you'll have a right skew. We're going to look at measures of the spread of the data in 2.7 in a separate video. Have a great day. Thank you for watching.